So I have made a Sudoku generator in Befunge. As you can see right here, it can generate Sudokus of size 2 up to 7, just like this. And it generates them randomly, so each time you get something different. You can try size 4. Yeah. So for Sudokus of size 4 and 6, you can choose between Sudoku with regions or without regions. So yeah, it generates it just like that. Yeah. And so this is a valid Sudoku with regions. But before I show you how exactly this works, I'll just briefly explain something about the language itself. So Befunge is an esoteric programming language and basically runs on a 25 by 80 grid, where each cell represents a specific instruction. So there are these instructions here, basically. So you can do some basic math operations, you can negate. Then there are these symbols which change the direction of the cursor. Then you can generate random numbers with this. This just points the cursor in a random direction. Then there's two comparators, a horizontal if and a vertical if. Basically, if the number on top of the stack is a 1, it goes to the left or up, depending. Well, not 1, but if it's a 0, it goes to the right and down, but otherwise it goes to the other direction. Yeah. Then there's string mode, which just puts the characters that are directly on the board onto the stack, and some other like manipulations with the stack, popping out of the stack. These two instructions, they take the user input, this jumps over the next command, and these two are basically an instruction which gets a value from the board. So if you can see, like in this position there is saved the value 58. So if I want to take this value, I can do that with this command. And the put command just puts the value that's on top of the stack, basically, on the board. And wait, I said it wrong. Oh, yeah, so this outputs the characters and this inputs them. And this ends the program. Yeah. So I can show you like the basic stuff right here. So as you can see, we can control the flow of the program with these arrows. This skips the next cell, so it would go like down here, skip it, go around here, and then jump over this again. Then we can put numbers on top of the stack, just like this, and then compare them. So if this is a 1, so this should go to the left. But now, if I go from below, put 0 on the stack, it would go here. Yeah, and this will just end the program. So as you can see, so it goes to the right, down, then it skips over this cell, goes down, jumps over, and then just compares it, it goes to the left, and now it goes to the right. So yeah, it's pretty simple. If you want to know more, just, you can try to make a program yourself. So now I'll explain how I made how the program functions, how it the core of the program works. So if you want to generate a Sudoku, well, you can do it different ways, but the way I do it in this program, I just first generate a valid solution, and then just try to remove each of the clues and solve it. And if it's possible to solve it, if it doesn't have more than one solution, then I keep it removed. Otherwise, I put it back, and yeah, that's how you get the Sudoku. And there's multiple ways you could represent which numbers are in which cell. And the way I do it is just like in binary, basically, like the first thing you would come up with. Yeah. So I've colored the program and made it easier to see like individual parts it's made out of. And so as I said, like this first generates the solution, and after that it generates the Sudoku itself, like the clues. Yeah. So it can be split up into, I would say, 5 parts. So the first part is it takes the user input and like sets some values that are used in the program further on, so that it doesn't have to compute them all over again, like each time I want to use them. Then the second part is the generating the solution. The third part is generating the clues. Then also there's this part which prints the Sudoku at the end, and the last part is this big function here, which solves like a given state of the Sudoku, you could say. Yeah, which is used both by the generation when I generate the solution and also when I generate the clues. This function is used with both of those loops. The program starts here, it goes down, and then in this part here, it asks the user like what size the Sudoku should be. If it's a 4x4 or a 6x6 Sudoku, it asks if the Sudoku should have regions. Yeah. So for a Sudoku of 4x4, the regions are 2x2, as you can see here. Yeah. And if the Sudoku 6x6 has regions that are 2 high and 3 wide. So the regions itself are like 2 beside each other and 3 on top of each other. Yeah. So this is the part here, and then down here, as I said, this sets the like important numbers. Then this red rectangle here, this sets the initial state, which basically is like a state where there can be any number in the Sudoku in any cell. So yeah. So then to generate the solution, what I do is that I choose a cell that can have multiple values in it, and I just decide like randomly which number will be there. And what I do then, I call the solve function, and it like tries to solve it as much as it can. If it fails, so if at any point the generation of the solution fails, like this whole thing resets and comes back again, like to this red part here, which resets it. Yeah. But if it doesn't fail, then it like I choose a number, the solving function will solve it as much as it can, and then I will choose a number again. Yeah. And when there are no numbers to choose, then this means that the solution is generated. Yeah. So that's how I generate the solution. And yeah, also so that you know like where this happens. So this part here checks like if the solution is already generated, and otherwise it takes care of choosing like which cell has more multiple values, and also it will like detect if like something was chosen wrong and the solution isn't possible anymore. Yeah. Then this part down here, this basically so this function takes a like chooses a number, like chooses a cell in which there are more multiple values, as I said, and this part here just takes a random number from those numbers that are left in that cell, and then it goes down here into here, and this starts the solve function, and then the solve function ends here and it goes back again into here. Yeah. So now that we have a solution, we need to generate the clues. So how I do that like this. So I like try to remove each of the numbers, each of the clues. I try to remove them. Then I call the solve function, which tries to solve it. And if it is possible to solve the Sudoku, I will keep the number removed and choose another number. Yeah. And to go through all of the numbers, I first need to generate like their indexes. So from 0 to, if it was a 5x5 Sudoku, it would go from 0 to 24. Yeah, you get the idea. And this part here this is called before the solve function, and this generates the indexes, like it generates the IDs from 0 to 24, for example, and then goes into this loop, which this is just the implementation of the Fisher's algorithm, which shuffles them randomly, 100% randomly, so that each Sudoku is unique, or not unique but random. So now that we have random, like we know in which order we are going to try to remove the clues, we need to remove them. So this goes down here, and basically this thing here does that it copies the board, because when we are solving it, we are like changing the values. So we need to know how it looked before we like solved it, so that we can then remove another clue and another clue and so on. Yeah. So this removes the clue, then the random clue that was selected that would be removed, we set the value in that cell to like an empty value, which means that there can be any number. There can be like all of the numbers in the cell. Yeah, and then it goes here in the solve function, and it returns here, and then here it goes to the left and comes back here. And this part here, this just checks if the solve function was able to solve it, and if it was, then the clue gets removed. Otherwise, the clue gets put back. And also, like, because we copied the solution, we need to like put it back. So I think, so that's this part here. This part here puts it back. I'm pretty sure. Yeah. And then it goes here, and it splits here. Either it goes again into this part, or if like the clue that was removed was the last clue, then it prints it here. So now there's the last thing remaining here is this solving function, which just solves a given state of the Sudoku, which is both used by the this solution generator and also when I am generating the clues. So it all functions like on a loop, which always like solves the Sudoku once and then checks if anything changed. And if anything did change, then it solves it again. And it continues this cycle like until there was nothing that changed. So that means that the program can't solve it anymore, the Sudoku, and the function ends and loops back. So this is the main thing that checks if anything changed, and if anything did change, it goes here, which starts like, I will call it a like one solve cycle. Otherwise, if nothing changed, then it goes here like to the right and up here and ends. And also if like it wasn't possible to solve it, like something went wrong, so that can happen only when I'm generating the solution, then it exits out here, and so that's that. So now how the solving cycle works. So because I need to solve, like I go through each row, each column, and each region, and I need to like solve hidden singles and naked singles. That's the only things that I solve here. Like there's not really space to solve doubles or even triples. Yeah. So these two boxes do the actual solving, and because I want to make it easier so that the code doesn't take a lot of space, I just copy like the values from each row and each column. Always I copy them like here, and then I can work with that here in this when I'm solving it. And to do that, I use like these pairs of boxes, which is always like this dark gray one and this gray one, and this dark gray one copies, like I think this one is for the rows. I'm not really sure, but I think this one is for the rows. So this goes like, first it goes through the first row and copies it. Then it calls this function which solves the row. And then this function exits here, goes here, and back here. And this saves the values back into the state, into the state that it's solving. And yeah, either it goes into the second row and then the third row, and when it reaches the last row, it goes back, it goes down here into the next, like, because after I solve the rows, then I solve the columns. So this goes here and this solves the columns. So this goes through the first column, solves it, and then back here, it goes here, and this saves the column, the solved column, back into the Sudoku, into the state. Yeah, and when it goes through all of the columns, it goes down here and checks if it should also solve the regions. Yeah, so for 4x4, 6x6, as I said, it solves the regions. And if it doesn't, it just goes back here and back again into here. So that completes the one solving cycle. Otherwise, it goes here, this loads the regions, like this goes through each region, loads it, loads one, solves it, and then here it saves it back. It saves it back into the state, into the server. And when it ends, it exits out here and goes back into here. So now that we know how this works, I'll explain briefly how I solve each individual set of cells that all need to be of different values. Yeah. So these three loops, they all exit out here, join, and then they go here, and then this part here solves hidden singles. And because I found it pretty hard to solve also naked singles in Sudoku, so what I did is, after it solves the hidden singles, it flips it right here. So this flips the values. I'll show you later how that works. And then it solves it again. So now it solves because it's flipped, it actually is solving the naked singles now. And then it goes back down here again, flips it, and because it solves both of them, then it goes up here and yeah, exits out here, which returns back to these gray boxes which save the solved state back. So now, because I have the possible values represented by the bits, individual bits, as you can see here. So this is what when I'm solving a set of cells that must be all different, that's how I interpret it. So this 15 is just for ones, this 13 is ones except this 2 here, yeah, and so on. And so I solve it. So this is what this red rectangle does. It solves, it goes through each row, and if there is only a single one in this row, then it sets the column to zeros on the other spaces. So this sets 0 here, 0 here, and here, and then yeah, the rest of those rows, they all have more than 1 0, so more than 1 1, so it doesn't do anything. Then it flips it across this diagonal, and then it solves it again. So you can see it's actually going through the columns now, but because it flips, I can still use the same function. Yeah, so it goes through this, it sets this to 0, which is already set, then it goes here, then this sets zeros to these two, yeah, and then it goes to the last row and sets 0 here. So that's this. So now it's done solving, it flips again, but yeah, it just so happened that nothing changed. And then, yeah, this is the result. So this is what is then saved. Yeah, and that's basically how it works. Yeah, I'm aware of the fact that it probably wasn't really comprehensive, but yeah, I didn't know how to explain this like in a short video, so you'll have to deal with that. But if you want to try like running this, I'll put a link down in the description where you can download this, and also I'll put a link to this site where you can use it. Also, I would be very interested if any of you tried and make this either generate bigger Sudokus than I have, because I can only generate Sudokus up to the size of 7, because like the values that I can save into these cells go from minus 128 up to 127, which is 256 values. But like, because they are negative, it's pretty hard to work with them bitwise. So that's why I only use like from 0 to 127, which can only represent a Sudoku of up to 7, size of 7. Yeah. I originally wanted to also include like an option to generate a diagonal Sudoku, which means that there can't, like, the numbers can't repeat on any of the diagonals. But yeah, as you can see, I didn't really have space for that. But yeah, if any of you like figure out a way to do that, like to either like make it generate bigger Sudokus, or also add the option to make diagonals, I would be very interested. So yeah, I hope you like this video, this explanation, and bye.